All right, eggs are off the heat. We're good to go. Now here we got real lucky that 3 different terms canceled, but it's not always going to be that easy. If I had an x plus 4 over an x minus 1, and I wanted to multiply that by an x plus 3 over an x minus 5, nothing cancels here. But what we can do is the numerator is going to be x plus 4 times x plus 3. So that's x squared. A 3x and a 4x make 7x. And 4 times 3 is 12. See, I FOIL in my head there? I know the first one's going to be x squared and the last one's going to be 12 because that's the first and the last. So down here, try and follow along with that one. First one's going to be an x squared again, x times x. Last one's going to be plus 5, negative 1 times negative 5. And in the middle, there's a minus 1x and a minus 5x, so that's minus 6x. So that's the product. You just multiply across the tops. This times this equals this. This times this equals this. It's that simple. Now, if you're trying to divide rational expressions, well, let's start simple. I guess constants are polynomials, so let's say I had something like 1/2 divided by 3/4. Yeah. I'll think of it this way. It's really the same as 1/2 when I'm dividing by something. That's the same as times a 3/4 but flipped, right? Because I'm dividing by a 3/4. I say 3/4 but flipped. I really mean it. 1/2 times 4/3. And then, well, heck, I could multiply across and make 4/6 and then cancel 2/3. Or I could have canceled to begin with and just made 1/1 times 2/3 is 2/3. With integers, it's fine to cancel before or after. With rational expressions, just because they're so unwieldy, we're going to want to cancel before. So let's do a couple problems. If I had x minus 1 over x plus 2, and I were going to divide that by x plus 5 over x minus 8, well, that's the same as, what do they call it? There's an acronym I've seen, keep, change, flip. If you've heard of that before, keep, change, flip. And keep this one the same, x minus 1 over x plus 2. Change that division to a multiplication. So we're going to multiply by the reciprocal of this thing right here. So we're going to flip that third one, just like we did in the integer example, x minus 8 over x plus 5. You can check my foiling here if you want to pause the video and try it yourself, or you can just watch me. This will be x squared minus 9x. Negative 1 and a negative 8 make negative 9. And negative 1 times negative 8 is plus 8. Down here, same process, x squared plus 7x plus 10. You see? Now let's do one more division problem. Let's do a, oof. That's a big division problem. All right, well, here we go. 3y squared minus 7y minus 6 over 2y squared minus 3y minus 9 divided by y squared plus y plus 2 over 2y squared plus y plus 3. Well, that's going to be a pain. Now, first step, okay, this is cheeky of me, but first step, how do we copy? First step is we're going to keep, going to change. Could never do this on a real whiteboard. And I'm going to flip these. Simple as that. Next thing we're going to have to do is factor all of these. So, geez, let's make those easy polynomials. Top on the left, slide the 3 over, y squared minus 7y minus 18. That's what I get when I slide and divide this guy. We slid, now we divide. That'll be y minus 9 times y plus 2. Put that 3 back in. That's going to be y minus 3, 3y plus 2. So this guy was y minus 3, 3y plus 2. Next one, 2y squared plus 3y minus 9. Minus, you know what I mean. They're going to slide, make y squared minus 3y minus 18. That's a lot easier because it's y minus 6, y plus 3. Pop that 2 back on in there. Get y minus 3 here. That's easy. This one's a y plus 3 halves, but we're going to write it as 2y plus 3. Same thing, but multiplied by 2. There's that 2 coming back in. So this is y minus 3. Oops. 2y plus 3. And look at that. Just like that. These two guys cancel out. But there's more to come. So third one. Let's go ahead and slide and divide this thing. 2y squared plus y plus 3 is going to turn right into y squared plus y plus 6. That's real easy. It's just, wait, what the hell? Add up to 1, multiply to 6. Something's wrong. Copied the problem down wrong. That doesn't factor. Let's go ahead and amend that problem and pretend I wrote the minus sign like I meant to this whole time. This should be a minus 3. Makes this a minus 6. I am changing the deal. That'll make this a y plus 3 times a y minus 2. All right. Slide and divide that. Over 2 over 2. I'm going to write this first one as a 2y plus 3. Write this second one, that's just a y minus 1. 2y plus 3, y minus 1, y squared plus... Wow, I did it twice. On my notes, this is a minus 2 because y squared plus y plus 2 is prime. That's what we call a polynomial that don't factor. If I had copied that as minus 2 correctly, it'd be y minus 1 times y plus 2, like I had in mind when I wrote this problem. All right, and what do we got? 2y's plus 3, y minus 1's. Everything cancels. Massive killing take place. 3y plus 2 over y plus 2 are the only terms left. I'm going to cut this video off here. Last video, we're going to do some adding and subtracting. That's all. So these will be 3 short videos.